In this video we will talk about two important concepts and natural things that we will need and will face in the networking. The first one is, if I have like 3 switches, and in order to maintain full redundancy, and by redundancy what I mean is that this switch 1, this is switch 2, and this one is switch 3. If I wanted to connect them all together, I can do this move, and that should be enough, because this end device can communicate with this one, and this one also. This device using this switch can reach and communicate with this one. So this is a network, all of them are talking together and we have no problem. But the concept of redundancy, is that just in case for any reason this cable went faulty or had a problem, then that's it. Switch number 3 is dead alongside with its devices. No one can reach switch 3, and it can reach anyone and can inform anyone that it has a problem. So as a matter of redundancy, let me grab and extend this cable in here. So by default I will have this topology where we can all talk this way. In case this cable went down, no problem, switch 3 still can go using this cable to reach these two, can go this way to reach switch 1, we have no problem. If this one went down and this one was already working properly, then this is the same original scenario. If these two were working properly and this one went down, no problem. So this triangle shape, this triangle topology, makes me have a full redundancy for any one of them that I want, and at the same time whatever single cable got failed, then no problem, this will not affect my network and will not cause outage. So this is beautiful. Okay, I have now redundancy, no problem. The big problem we have talked about in the VLAN lecture, in the concept of switching, I believe, was that the normal and default behavior that you cannot manipulate or change in switching or in switches is that whenever a switch for any reason received a broadcast message through some interface, it will automatically at the same time forward this broadcast message to all its other interfaces, but not the interface that the message came from. So this switch for any reason received a broadcast message maybe from here, from this interface. At the same time it will forward it to these two interfaces. This broadcast message will go now to switch 1 through this interface. What will switch 1 do? It will send it automatically to switch 3 for this broadcast message that came from switch 1, switch 2, I'm sorry, this one. This broadcast message normally will go to switch 3 through this interface, and this one through this interface. What will the switch do? It will take this message that came from this interface and forward it to this interface, and it will take that broadcast message that came from this interface and forward it to that interface. That makes switch 1 receives a broadcast message through this interface, which will automatically send it to switch 2, and this interface sends a broadcast message to switch 2 through this interface, from this interface to this one, to reach this, make this message reach switch 2. Now switch 2 also, just like switch 3, receive two broadcast messages, one from switch 1, the other from switch 3. What it will do, it will forward this again to switch 3, and it will take this one that received from here and forward it back to switch 1. This thing will continue to be happening forever, or until the resources utilization gets full and cause the switches to crash. Because as I said before, the broadcast message are heavy messages that do consume a lot of utilization of the resources, whether it was CPU or RAM. Okay, so all this scenario, all what's happening here, from being unable to control and stop the broadcast message, is called a broadcast storm. This was a storm. And another term, when you work in the future, or when you are, I'm sorry, you are already working in networking, you will call it a loop. Some other environments will call it a layer 2 loop, because it happened because of the normal or default switch behavior. Okay, so it will be called a layer 2 loop. So all of this happened, all of this disaster and storm happened just because I wanted to maintain redundancy, just because I extended this extra cable. Okay, in the old scenario, first when we had this topology and the computer or any device sends a broadcast message to this interface, what will happen that this broadcast message will be forwarded to this interface. After that it will be forwarded to this interface. After that it might be forwarded to this interface, and that's it. This will not be forwarded to another switch, so that this switch default behavior will re-forward it again to its other interface. So in this topology there is no loop. I'm sorry. In whatever topology you will face in the future, whether it was 2, 3, 4, maybe 100 device switches, I don't care about the number of the devices. Once you reach a ring topology, once you close your ring, just like what happened in here, when you have closed the ring, now you have closed area inside, whether this area was or triangle, square, or even a circle, a pentagonal or hexa, whatever. Okay, so once you close your ring, then you are suspected to receive a loop at a chance of 99%. You will have broadcast storm at this percentage, and you will have. Okay, this will always happens just because you wanted to maintain redundancy, just because you have closed your ring. This makes redundancy is a failure. This makes ring topologies are failure. This makes all of these networking terms and technologies useless. Okay, so at that time a new technology came. It's a real mess. Okay, a new technology came, was called the spanning tree protocol, the STP. Now the spanning tree will automatically, you must know that spanning tree, what will we talk about spanning tree in our CCNA is just talking and verifying. We will not configure spanning tree because it's completely automatic right now. In about maybe 99% of whatever switch that you will buy from the market, spanning tree is already enabled, will already behave. Once you extend the third link, all the devices will detect automatically and negotiate between them that a loop might happen. So please enable spanning tree automatically. Do the spanning tree process that we will talk about right now in the next, okay, in detailed, and no loop will happen at all. Okay, so what does spanning tree do? What does spanning tree do? Spanning tree do or solve or disable what we have previously enabled, which is, you remember that we had only two connections between switch 1, 2 and 3, and everything was normal. Once the third interface was extended, we had a big problem. which is loop. So spanning tree will automatically, what it will do, it will temporarily disable the new, or the third, not the new, the third extended cable. Okay, this will cause us to logically go back to the first topology. This will make us looks this way, behave this way. Okay, physically we do look like we have three cables, three connections. Spanning tree makes our network looks this way and behaves this way. Okay, like this one do not exist. Why? Because it disables one of these two ports, and when one of these two ports is disabled, this is like this cable is useless, this cable is not working, so we have no problem. We have solved the broadcast storm problem. Okay, all of the process of spanning tree is automatic, just like the process of the default VLAN that makes your switch have 24 interface. All of them behave in the same broadcast domain, lies in the same broadcast domain. So whenever you just join a device to your switch, it will operate normally and it will join the network. Okay, so just like VLANs are by default enabled in switches, just like the interfaces of the switches all are up and running and have a power supplied by default when you take the switch out of the box, also spanning tree is by default enabled once you operate a switch out of the box. Okay, you need to do nothing about this. Okay, you can disable it, you can manipulate it, you are not asked, or you mustn't know how to do this as a CCNA engineer, but what we are talking about is, you should know how do the spanning tree behave, and what is the spanning tree process, and how to verify that spanning tree is working, and which one is the ruler in the spanning tree topology. Okay, so in spanning tree, what it will do is that it will disable one of these two interfaces to solve the problem. Okay, what problem? I mean problem. What problem? The problem of this triangle topology. Imagine another type of topologies where I have this switch, this other switch. Okay, I have one fast Ethernet interface which gives me a bandwidth of 100 megabit per second. Okay, for transmission, and I just wanted to extend another one to make this two interfaces, maybe make it have a bandwidth of 200 because 100 is no longer enough. Okay, what will happen if a broadcast a broadcast message entered from this interface? It will be sent maybe throughout this interface to this switch, and this switch will receive it from this interface, automatically will re-forward it again to this switch through this interface. Once switch 1 receive it through this interface, it will retransmit it and re-forward it, to this interface, to this one, and this will continue to happen forever, and this is also called the broadcast storm or the loop. Okay, so even in these two switches, between these two switches, there will be a loop because more than a single interface is connected, so one of them must be disabled using spanning tree, one of them must be disabled using spanning tree. Maybe I have 4 switches, no matter how many, we will see this in the pack tracer. One of them will be disabled for a reason, and we will discuss which reason is that, why this specific interface is being disabled. Okay, so this is the only concept of spanning tree, of why the spanning tree were invented. Okay, we need redundancy. There will be a broadcast message. After the broadcast message, there will be a broadcast storm or a loop. So spanning tree will requires an election to perform. First, election of what? Okay, you want to know, when you enable spanning tree, or it's already enabled by default, which interface will be disabled. Actually, this will not be your concern in spanning tree. Your concern in spanning tree is that which interfaces will stay on and operating. So once I eliminate all the interfaces that I need, the rest interfaces will get disabled, because not just a single interface will be disabled. Why? Let me tell you. What if we had 2 cables extended between each of these? Okay, so 2 cables between switch 1 and 2, two cables between switch 2 and 3, two cables between switch 3 and 4. Okay, and there was a broadcast message forwarded from here to this one, so it will be immediately forwarded back to switch 1 and to switch 3 through these two interfaces, because this is the broadcast behavior. When it reaches this interface through this switch, through this interface, it will be forwarded to these two. When switch 1 receives it, from these two interfaces, it will forward this one to this one to this one, and both of them through these two interfaces. So this is not just a storm, this is a catastrophe. Okay, this is not just a storm, just because we have two cables extended between two of them. So to solve this, we need to disable more than a single interface. Why not just one single interface? Because maybe this red cable was disabled, but we still have a closed topology. Okay, there is a closed triangle because of these blue cables. So two cables in this state might need to be closed. Okay, when closing these two or disabling these two interfaces, is the problem solved? No, because if you remember the scenario of the two switches having two cables, okay, what happened is that this switch and this switch right now have two cables between them, so there is also a loop in here. So disable this one maybe. Okay, these two switches still have these two cables between them. There is also a broadcast storm might happen in here, so please maybe disable this one. This leads us to 1 2 3 4 disabled ports just because we extended extra cables. Okay, so I have 1 2 3 4 5 6 7 8 9 10 11 12. I have 12 ports. 4 of them are disabled, only 8 left because of spanning tree, because the concept of entirely and completely eliminate the probability of a broadcast storm or layer 2 loop. Okay, so your request, your concern will be to know which ports will stay up, which ports will stay up and running. Okay, so to know that, election must be first performed. Okay, to perform election, take this away. Okay, this will be about 18 minutes, so let's take the election to the second video. Okay, how this was clear enough. In case only the concept wasn't clear enough, please comment down in the video, subscribe, follow our channel, comment in the video that if you have any concern about the spanning tree concept. In the next video we will start with the election process. Okay, so thank you for watching.